Welcome back to this 10th installment of Beginner's Guide to Understanding Chemistry. In this lecture, we'll talk about chemical equations. Thus far, I hope you guys are enjoying the chemistry that you are hopefully learning in this video series on your way to learn these higher forms of pharmacology that we will eventually get to. As we've seen a little bit before, chemical equations tell a story about the behavior of molecules inside of a system. This behavior describes the reactions they undergo when they react with one another. Here's kind of what they look like. Basically, this equation describes what happens to atoms in a chemical reaction. Basically, what happens is on the left-hand side of this equation, covalent bonds break, and on the right side of this arrow, new covalent bonds form. For example, in this reaction, we have this molecule, which is H2, another molecule of H2, combines with O2, or diatomic oxygen, in the air. These atoms undergo a molecular rearrangement when these covalent bonds break, and this gives us a molecule of water and another molecule of water. We call this side of the equations to the left-hand side of the arrow the reactants. On the right-hand side of the equation, we call these products. What we should always remember is that the amount and type of atoms on the left-hand side of the equation should always equal the amount and type of atom on the right-hand side of the equation. And what I mean by that is the amount of hydrogens and oxygens on the left-hand side of the equation should equal the amount of hydrogens and oxygens on the left-hand side of the equation. More specifically, on the left-hand side of the equation, there are 4 hydrogens that are in that whitish gray color, and there are 2 oxygens that are in red color. If we were to go to the right side of the equation, we would see the same thing. There are a total of 4 hydrogens in white and 2 oxygens that are in red. Furthermore, when we write out these chemical equations, we don't write them out in this longhand way. As chemists, we condense this into a smaller, much easier to understand model that is a bit abbreviated. So how we generally write this is we do the following. We take the 2 H2s, combine them together, which will give us 2H2 plus O2. You see these things in parentheses labeled G? We indicate the state of matter that these compounds are in. G indicates gas. These are called physical states. We often denote these as S for solid, like ice water, L for liquid, like liquid water that you drink, and G for gas, which would be water vapor that you boil and it is steaming into the atmosphere. This equation goes to or yields 2H2O liquid, which denotes the state of matter. This is the much more condensed, abbreviated way that we as chemists like to write out our chemical equations. There is one more caveat in the way we as chemists draw or write out chemical reactions, and it's called the special condition. For example, you can actually run this reaction that we saw in reverse. If you take liquid water and basically run an electric current through it or electricity through it, you can break the water molecules apart, breaking their covalent bonds, and reform 2H2 gas plus O2 gas. Notice how in this chemical reaction, the water is the reactants and the H2 and O2 are the products because we ran the reaction in reverse. This thing that we draw over the arrow that says electric current is called a special condition. It's a specific environment that we run the chemical reaction in order for that chemical reaction to occur. This one, for example, is 2KClO3 solid. We can basically take this run it under heat. This triangle indicates that we can run this reaction under constant heat. We can break this 2KClO3 apart to form 2KCl solid and 3O2 gas.